Well, that's it. Just by way of introduction, the two of us that you see on your screen, who are we? My name is Jaco van Niekerk. I am the portfolio holder for eTeacher or capacity building in the Western Cape for e-learning integration, or ICT integration. So effectively, what that means is my job is to ensure that more teachers learn how to integrate technology more effectively into their teaching practice. Louis is the e-learning advisor in Overberg, and he's a very avid supporter of the concept of coding. He's an avid supporter of coding itself, of programming, and he used to be an IT teacher and had lots and lots of years of actually teaching IT. So for him, this concept of a coding club and what a coding club is incredibly important, and really something that the two of us have spoken about at length. How do we get people to latch onto this idea a little bit more, and how do we move this whole thing forward? So, Louis, I don't know if you want to add anything to that.
No, Jaco, I think you covered the basics. IT teacher, e-learning advisor, passionate about coding, thinking this is important. No, you got it.
And spent way too many time looking at all sorts of different options out there for how do we actually do coding. Right, so now, if we want to get into it, there's a simple reason why we wanted to put this session together. And it comes back to the idea of, let me just get a second. Right, it just comes back to the idea of we want to focus on the concept of coding. Very important, and I'm going to explain why we want to focus on the concept of coding specifically. And what we also want to make sure is that we have an hour effectively. In 1 hour, we want to jumpstart that whole idea, that process. We aren't going to necessarily show you everything, but we want to jumpstart the process of how do you start a coding club at your school? What are the basic steps you can take? What are the processes? What can we share from our experience? Could be those things to get you going and to get you moving. I see there's already some chat happening there. If you have questions, please type it out in the chat. Both Louis and myself will be monitoring it and responding from time to time. But yes, right. So the critical thing with the whole coding thing, I think a lot of people have been talking about coding and robotics, and there's a lot of talk about coding and robotics, coding and robotics, coding and robotics. There's a reason why we wanted to just say coding. Louis, do you want to elaborate on why we said coding and not necessarily coding and robotics?
Okay,
for this session.
The moment you bring robots into the session, then it becomes a monetary issue. They're going to be expensive. The kids sharing them, you have one per kid, that type of thing. It's also then third party people like to just sell you things, and then it brings like, who should I buy into, not buy into? And in my experience, it basically just blocks everyone from actually starting a coding club, because you can always bring robots later on and add. That's easy to do. But the coding is the actual hard part to grasp. You can apply that to any robot. But let's start with the coding. That's where the core of what we want the learners to learn, the skills. That's where that lies.
Louis, I don't know if you want to just answer that question. Hannes, I see, is posted there is asking about the coding curriculum. And I think this coding club thing that we're talking about ties into the coding curriculum question. I don't know if you just want to fill that one quickly.
Hannes, for now, there is a draft curriculum out, which you can just Google and download already. It is for the subject called coding and robotics, which is a horrible misnomer because it's about 80% not robotics. So robotics is a smaller element, and you can probably do 80% of that curriculum without a robot. It's actually it's more like digital skills, how to be a digital citizen, how to be safe online, etc., and then coding, and then a little bit of robots, and then a little bit of Office and then PowerPoint and Word and stuff in between. So yes, there is a curriculum. It's a draft curriculum, should be published sometime soon. You can Google and download it so long that is out there.
Yeah, I think it's the critical thing with the coding and robotics curriculum, as Louis pointed out, at the moment the subject is being called coding and robotics, but the focus is on digital skills as a whole, not coding and robotics. Coding and robotics forms an element and a component in that thing, And this is a lot of people a little bit worried and scared because there's not a lot of experience and skill around this concept of coding and robotics. So when we looking at the coding and robotics concept, we wanted to focus on coding specifically because we just want to highlight how we can get going with it. As we pointed out, it's a lot simpler to just start off with coding rather than wanting to go for the whole coding and robotics part. It is something that you can always add at a later stage as well. Right. So, but first and foremost, there always needs to be that question, why? Why on earth does this matter? So what is the hype around coding and robotics? And in our instance, what we're going to be focusing on is what is the hype around coding specifically? Because, I mean, it's kind of the same thing, and we'll get to the robots later as well. I promise we will talk about robots as well. Right. So first and foremost, and for me, I think Louis and I differ a little bit here, but for me, the instant feedback component of it is the most important part of it. Now, I was an English teacher, not a IT teacher, and instant feedback, if any of you were able to attend any of the sessions that we had over the last few weeks on assessment for learning, how digital tools can add to that, you should know by now I'm a big fan of this concept of instant feedback because it allows both the teacher and the learner to know instantly whether or not they've got something right or wrong. At the moment, we send learners home with homework, they answer questions, and they have to wait 12 hours or however long to actually know whether or not they got it right. Even worse, we let them write a test, and then we mark that test. And 2 weeks later, we tell them, oh, thank you for trying, you got it wrong. I would love to believe that most kids write things down that they think are right. But the real world, if you think about it, works on instant feedback. My analogy that I always love using, climbing trees. If I climb a tree and the branch breaks, I instantly know that didn't work. It just immediately. I can't find out later that it didn't work, because if I find out later that it didn't work, I probably fell out of the top of the tree at some point, eventually. And this is kind of what happens in our schools. Of kids find out later on that they got it wrong, and then every other step also was wrong. So, Louis, in terms of instant feedback, how does this apply to the coding world?
Jaco, it's a perfect natural fit for instant feedback. The moment you start teaching a kid a skill in terms of coding, he can immediately see, is this working or is this not working? What's nice for me about that is that the basics, because everything builds on everything else, he immediately knows if he's got the basics under control or not. And once he has the basics, he moves to more advanced. And so there's no time lapse. There's no going 2 weeks ahead and then finding out, oh, I got lost somewhere on the way. It's just instant feedback. Also instant motivation, saying, oh, I did get this right. And that motivation builds and builds confidence. So it's a very nice thing, this whole instant feedback loop, instead of having to wait for anything to come back to you, to just know where you are in terms of your skill, you can see immediately.
And very closely related to the concept of instant feedback is debugging. And this is such a critical component of learning, of growing in anything, that we're not addressing enough in our everyday learning that we're doing. So I'm going to give Louis the opportunity to talk about debugging in coding sense first, and then I'm going to bring that in where I see this as relevant in the rest of our curriculum as well. So in coding, what is debugging? What on earth does that mean, Louis?
Debugging actually comes from when they had these huge computer programs that were buildings, and they could find a physical bug in the computer, and that was, a problem. But debugging is finding a problem and then fixing it, having to figure out what's wrong, what went wrong, why the program's not behaving in the way that you want it to behave. And it's more than just debugging. It even ties into the psychology of our learners, where I taught girls as well as boys, and I did a lot of studies of this, and it came down to our girls are programmed to be these perfect little girls, not to make mistakes. And then they come to me in coding, and then they suddenly realize There is no coding without mistakes. It's inherent to the process. You make mistakes, you learn from them, and it creates confidence for them in a different way in how they approach problems, knowing it's fine to get a bug or a problem or something to go wrong, and then you learn from it to move on. So it's a wonderful learning opportunity for all of our learners, boys and girls.
And to take the classic cliche statement, that whole fail forward concept,
Yes.
I had the wonderful opportunity to visit a school not too long ago where we went to I think it was a grade 2 class that we were in, and they were doing silent K sounds. And we had the opportunity, the learners had to write these things on the board. They had a lovely PowerPoint presentation up on all these silent K sounds, which they needed to then go and write on the board. And one of the advisors also had the opportunity to do it. And I mean, playing along to the whole thing, said, "Ooh, maybe if I get this wrong." And one of the learners, and I thought this was absolutely beautiful, told the e-learning advisor, "You know what, ma'am, in this class, it's okay to make mistakes. We're encouraged to make mistakes because we learn from mistakes." I have a 4-year-old, a 5-year-old, and a 1-year-old at home, and they make mistakes constantly. But because they are allowed to make mistakes, and they have no fear of making mistakes, they're also learning at a rapid rate because they learn what doesn't work. So with the debugging concept, I mean, in languages, for my background, if there's a spell checker is a classic example of a debugger. You've made a mistake, spell checker tells you got it wrong, you fix it. Now the sentence has been fixed. Right, there was a bug in the sentence, effectively, it wasn't right. Grammatical things as well. We've got Grammarly, we've got so many tools these days that can help us do this. And it gives you confidence. I mean, if I look at how many people weren't confident English writers, and now with the use of tools like Grammarly, feel more confident because they know they can fix their mistakes. I think it's a critical thing, being brave in that sense. Now, the abstract thinking thing is a weird concept and unbelievably important in what we are doing and what we are supposed to be teaching our learners, but completely undervalued and under actually taught. I think it's a complex thing. So, Louis, it's too complex for me to explain. I'm going to ask you to explain it, please.
Abstract thinking, in my understanding, is your ability to envision an inner world, to see a problem inside of your mind's eye. For example, if you want to explain to someone how to get to your house from the school, and you would say something like, leave the gate, then turn left, continue until you hit a stop street, and then turn right. And as I'm explaining these directions, if you've been visualizing this, then you've been using your inner world or abstract thinking, just one application. And computer programming is inherently abstract thinking because you're typing things on a screen or dropping blocks in sequence below each other. And this creates something or solves a problem or behaves a certain way or does something. And that's abstract turning into concrete, but you have to have that abstract thinking. And one of the things I picked up through my years of teaching IT was I would get these kids in grade 10 and they're wonderfully keen. They want to learn about computers and be programmers. And I would soon realize that they have no abstract thinking ability. They've never really developed it. They live in a concrete world with concrete problems and solutions. And now it's my task to start teaching them this completely new skill of having an inner world of visualization, of seeing problems from abstract to concrete. And that's what coding brings to us. That's what we need. Kids that go into grade 10 or into life with abstract thinking ability.
So when I said Louis and myself, we disagree a little bit. I love the instant feedback thing. I think it is absolutely critical. But as someone who taught IT, I think he believes abstract thinking is one of the most critical things, because abstract thinking ultimately, I think, it leads to problem solving. It simply latches onto it. The ability to visualize in your head, if I do A, then B will happen, and C will happen, and D will happen, and D will solve the problem that I have for A. Visualizing it in your head, imagining how these different steps and different blocks build together to solve problems. And at the moment, when it comes to a lot of what we do in the education and our curriculum, the CAPS curriculum, we're solving simple problems sometimes. We have a maths problem, it's a simple problem. It's not necessarily an abstract problem that has a lot of variables in it. In other, I mean, in other subjects, and obviously I'm not trying to be look down on any of these things in any way, because no complex problem can be solved if you're not able to break that complex problem into multiple small problems that you are able to solve one by one, that kind of analytical thinking. But the ability to do that complex problem solving is 100% rooted in abstract thinking, 100% rooted in the ability to imagine it. I hope I kind of just explained that well enough, Louis.
Yep. Both of the solutions opportunities we're going to present today actually start kind of with the concrete, from start moving something on the screen and taking it to where it is actually abstract. So we start with the concrete and we move very quickly into the abstract. That's very nice.
Yeah.
Can everyone still hear me?
Yes, I can.
I see you. Okay. Now, with problem solving, I think one of my biggest skills as a teacher was to actually pretend to be an idiot. What I would do is I would have these kids come to my classes. Some of them got 95, 99%, 100% for mathematics. They would be very smart, but they wouldn't know how to solve a problem because they're so used to learning formulas or to getting it right that they don't, when they're confronted with something completely new and difficult, they don't know how to break it down, how to try something that you get wrong and then learn from it and then try something else. So I would put the problem on the board and I would, one by one, step by step, I would get it right and then I'd get it wrong. And then I'd wait for the kids to realize. And some would start bubbling and laughing and hands would start going up and, sir, you did something wrong. And I'd have them explain to me how I actually got things wrong. And so through the years, I'd build their understanding of how I solve problems and approach them. And sometimes I would take difficult problems and I would get it wrong. And by my matrix actually knew honestly where my own ability was in problem solving, because I would have very advanced problems on there that we would solve as a class, and sometimes I'd get it wrong, and sometimes some of these kids would get it right. Kids that were blatantly smarter than me, I would celebrate that with them because that's my job as a teacher, to lead them to learn more and to grow. And then it was wonderful to see how they would solve problems, and sometimes their solutions were even better than mine, and I would say, you know what, your solution is better than mine. Well done. Whole class, learn from this person. This is what we need to do. And so problem solving for me was just like this fun activity of getting things right, getting it wrong, keeping them guessing as did I do it on purpose, did I not? It was fun for me.
And I think what Louis has mentioned here that is absolutely vital to the idea of what we are talking about is it is a club, which is inherently a social thing. A club, the concept of a club is not a classroom. It's not that. This is not what we are referring to. And I'm glad someone asked about the curriculum because it's a vital part, the question that we have about that. But we are referring to the idea of an extramural thing that you do. If you integrate it in school, it depends entirely on how you want to do it, that's great. But what we're specifically referring to is a group of learners that are coming together to learn about this thing with you, not necessarily from you. And I think this is an important thing. They're not learning from you, they're learning with you, and they are learning with each other. Coding is, it's one of those strange things that everyone knows the stereotype of what a programmer looks like. It's this basic white guy who never comes out of his basement and has never talked to anyone before. Coding is an inherently social thing. It really is. It's an incredibly fun thing to kind of work with people and learn about how things are working, not doing it on your own, working alongside people and discovering solutions. So the question is now, what do you need in order to start a coding club? Do you need to have brilliant abstract thinking skills? Do you need to have amazing problem solving skills? What are the things that we need? Louis, I see is my connection a bit choppy on your end?
I would say every 3 minutes you get about 10 seconds of choppiness. So it's okay. I don't think you need to worry about it.
Okay, I can turn off my camera if it's going to improve the audio maybe a little bit.
No, I think it's okay.
Okay, cool. So what do we need? We need enthusiasm. Really, if you are enthusiastic about this, that's kind of almost where it stops. There's one more secret ingredient, and that is curiosity. Now, I'm hoping that the fact that you are in this session means that at the very least, you are curious. So there we go. We've at least got that part sorted out. Now, what we want to also help you get to after this hour session that we have is we want to make you feel enthusiastic about the fact that anyone can do this. And then do you want to add something here, Louis? I know you've got a great story about some of your colleagues as well in the past.
About my colleagues, don't know what you're referring to right now, but I can tell you that starting a coding club means you are a facilitator of learning. It means you are dedicated to giving that half an hour or an hour a week to get these kids to learn to code. And they're going to surprise you, and they're going to do things you're not expecting. I had a kid in my class who taught me how to do mobile app development. I had no idea. He actually suggested some free resources, and together we got better at that. And another kid with some low-level programming and building games. And even though he surpassed me completely because it wasn't my interest, I could see how it developed. And if you just put in the effort and the time to facilitate these learners to learn coding, it just requires enthusiasm and curiosity. You need to know very little of coding. You can learn with them at their pace if you are interested, but they just need a dedicated adult with enthusiasm and curiosity, and that's what they need.
Yep. Because let's get to some of the adult things that you will also need to do. So before we get to the adult thing, well, this is also adult, I suppose, but the first and the most difficult steps to starting your coding club are actually the following two things in my mind. They are, firstly, you need to go and explore. You need to go and find out what is out there. You need to go and figure out what are the options. You need to go scratch around. You need to go see what it is. And then, possibly even more challenging than the exploring part, is you actually need to choose something that you're going to then say, look, this is the one we want to use. This is the one we're going to bank on. I have looked at a whole variety of different things. I am now going to pick this one is the one that I want to use. And this is the part, I'll be honest with you, that can actually be very overwhelming. Because the strange thing about programmers and coders, whatever you want to call them out there, is they are very happy to share their knowledge. They actually really, really, really want to. So you get so many, when you get to this exploration part, there are so many free resources out there to learn coding. You really don't need to spend anything at this point in time when it comes to coding stuff. There are so many free resources out there. The choosing part can be a little bit more challenging, and I think this is a part that we want to come in and we want to help you a little bit. We want to put you on a shorter exploration path in the sense by showing you what, based on mine and Louis' experience, what we think are good options to start. You don't need to go with only these. There are lots and lots and lots of other things. We are going to share a document with you that Louis compiled with a lot of his suggestions on great resources that you can continue to explore and go and find out what they have to offer. But we want to show you just a couple of cool places where we think are good places to get started.
Jaco, if I could just mention that our aim and our focus, especially our resources for this moment, is focused more towards the younger learners.
Yeah.
Now we're talking anything from grade 4 onwards. I think foundation phase has got their stuff mostly covered with the Lego 6 bricks, so that's fine. But we are focusing more on the slightly older kids. But definitely this could be a preparation for joining grade 10 IT as a subject, which would be wonderful, or for a learner to then go on for the grade 10 and use some of the resources that I linked at the bottom of the document to continue on their own learning online, facilitated or not, to become programmers. I have a ridiculous amount of programming friends, and they make a ridiculous amount of money, and half of them are self-taught, who taught themselves from the internet, spending zero money at university. And what we do with our kids is we can build towards that kid with a bright future that started coding at a young age, that might come back to you one and say, thank you, sir or ma'am. You know, my whole coding journey that changed my life, my family's life, all of our lives started with you playing simple games with us and making it fun and facilitating our learning in the beginning.
Because I think ultimately there's one of the things we also want to encourage is there are near endless opportunities for coders out there, and you can, and again, it is a very, very good potential income that can really uplift. I mean, it can have enormous economic impact and enormous economic repercussions for our province. So I mean, in general, it's just a good idea. It really is. But well, we are obviously convinced of it, so we're not going to try and convince ourselves even anymore. Now, when I said this is kind of the more, we tried to break it down. If you are enthusiastic, if you are curious, we're going to start showing you after this where we recommend you start exploring. But keep the following things in mind, because I think you don't want to be completely rogue and renegade in what you're doing. You will have to discuss this with management at school at some point. I'm yet to meet an SMT that is against the idea of coding, because everyone thinks it's a good idea. So if you come up with a good plan, I'm sure you will have the support. Then, of course, this can be a little bit more tricky. You'll need to find a venue that meets the requirements. Now, when it comes to the requirements, you don't actually have to go and buy additional software. The mini PC labs that most schools have, perfectly fine. The
tablets that were just delivered to all our Mobi Suite schools, perfectly fine.
Tablets are perfectly fine. So Mobi Suite schools that receive tablets are perfectly fine. Schools that receive tablets from the Stats SA projects, etc., etc. There are lots of opportunities and lots of devices that could be used for this. We've even spoken to people who started coding clubs using old cell phones, because you can do that. A lot of these things work. I mean, I don't want to do all of those things on an old cell phone, but when I taught my learners, they were writing 450-word essays on cell phones because they get used to working on these small screens. They're comfortable with it. They're familiar with it. I don't know how you do that.
I read about a guy that started coding when he was 16 on a cell phone, writing web pages. And he went into front-end development later on, but it was in Kenya, and he started working something like a Nokia 3310 or something ridiculous that had a text editor. And he realized you can upload text documents from a phone to a web server, and that's how he built a career as a programmer with his Nokia phone, just because it can write text. And if you can write text, you can program.
So I wouldn't recommend trying it with the Nokia 3310. No. I would not recommend that. So smartphones, and at least for this, but still, just to give you an idea, then you can set up your schedule and you start advertising to your learners. You need to keep in mind you will have some restrictions, I'm sure, that comes in with the venue that you have. You won't necessarily have all learners in your school involved in this. But I mean, these are the logistics that are going to be different for every school. What we want to try and emphasize here is it does not need to be that challenging. You need to consider that you want to do it. I know in our previous recording, I said the statement, and I mean, it still remains as true. 100% of people that didn't start coding clubs still don't have coding clubs. So yes. It's a matter of starting it and trying it. And it's going to be messy. Yep. You'll make mistakes. But if you remember what we said about the whole debugging thing, that is the only way to figure out what will work, is to actually get going with it, figuring out what the mistakes are, and then moving on from that.
You also don't have to start with 20 or 30 or 100 kids. You can start with 5. I know a school that's got a dedicated coding club for 2 kids, run by their ICT assistant. He just spends, I think, it's half an hour to an hour each week after school. He goes and sits in the computer lab with them, and they just follow the next lesson in the program. And that's it. And these kids are learning to code, and it's a wonderful experience. And I'm very happy for the opportunity that he's providing those 2 kids.
And Louis, I will guarantee you, next year it won't just be 2 kids.
No. The year after that, it's going to grow.
It's
but
going to
start
grow.
small. Keep it manageable for yourself.
Yes. That's the critical thing, I think. Don't be overly ambitious, but start. That's the critical thing. Start. So
it's kind of like MCO. I tell a lot of schools, do not register all of your learners when you've got 20 PCs and 1,800 learners. Choose the grades that you register. So choose your learners well.
yes, that's very true. So just a second. So what we're going to do is we're going to suggest to you why we think these are good places to start exploring. So the first one is a thing called code.org. Louis, what do you like about code.org?
I love the simplicity about it. I love the fact that it is very structured, as in you can register your classroom and get your learners to join the classroom, and it tracks their progress through each of the lessons. I love that you can literally see a lesson turn green and the next one turn green. So every week you could provide them with time and you can facilitate their individual differentiated learning as they complete this at their own pace, and you possibly help them. If you can help them, it's great. If you can't help them, eventually they'll help each other. I mean, there's nothing that says you can't have the best coder in the class help the other kids. I mean, you can literally just ask them, go and help the other kids. I've done it many times. It works. So the structure, the simplicity, the fact that you keep the track of the progress, and it's completely free. And when I looked at the skills covered, these are the perfect skills. These are the basics of programming. Hell, these are some of the more slightly advanced concepts of programming. If I had any grade 10 learner that went through this code.org course before he arrived in my class, he would have been an 80, 90+% achiever in coding, no doubt in my mind. I wish we had more learners just going through a course like this before starting IT.
And just to add to this, to add some gravitas to what Louis was saying, he was also an NSC marker, so he does know what he's talking about when it comes to the IT curriculum, at least. And I think, to me, that was one of the most valuable things in chatting to Louis about this. And we're going to go into this now and stop talking about this as an abstract concept. But the fact that I looked at this, I thought, this is pretty cool. And then I spoke to someone who actually taught learners IT from grade 10 up to grade 12 level and had brilliant learners in his class that struggled. And the fact that he said this, playing games, and I'm just going to run it, this idea of playing games, it feels like a game that you're playing, would have been so useful for his learners. So let's have a look at code.org. Now, when you open up code.org the first time, and this is the part where the facilitation can, I think, be very important. Code.org is super straightforward and simplistic. However, one thing that I can really criticize to them is if I open up this thing the first time, and I am a 10-year-old kid, I don't know where to go. I don't know what to do. This is the one part about it. I would have loved there just to be a button that says, click here, get going. But there isn't. So what we want to show you quickly is pretty much where you do that, effectively do that. And it's scrolling down and getting to this part where we say, students, explore our courses, blah, blah, blah. So I'm going to click here, go to students. Right, so let's open up the students part. I want to now just go to the grades K to 5. So basically our small, well, let's go to grade 6 to 12. Now, actually, no, I want to show you something else. Come now. Let's go back with the K to 12. Right, so when it comes to this K to these courses, there are two courses here. I'm not going to go into the pre-reader express, but I think this is a very useful thing if you're going to be working with very young learners or learners that do not have any kind of experience using computers, because the pre-reader express literally starts off with the basics of clicking and dragging blocks into each other, how a mouse works, how I move one thing over to another thing, that whole concept. I think it's really, really, really good to get them started with that. However, we're going to go and dive into the Express course, assuming that there is some understanding how these things work, at least. Right, so what does it look like? And Louis, please stop me anytime that you want, or add to what I'm showing.
No, they're in good hands. We've got a
Right.
lot of good comments here, by the way. People saying, I incorporate go.org with my learners in their weekly computer lesson. I incorporate it with my grade 3 to 7s. I do it with my 8s and 9s before subject choices. We have people that's been teaching learners
That's
coding. They
amazing.
just don't know that they could say, well, this is a coding club if they wanted to. It's
That's
amazing if you
awesome.
read these
That
comments.
is. No, I'm just skimming over it. It's awesome. So what Louis pointed out is the fact that it's straightforward. It's simple. In terms of the visual side of it, you'll see there's the first part where they learn about sequencing. It is sequential in the sense that it starts off with 1 and it goes to 13. So you go through steps and you learn through the process. Now, this express course, which is like a kind of a beginner course, if I scroll down, you'll see it's going to keep you busy for a while. It's not a quick get things done in a week type of thing. It really is a long process that you run through from the start to the end. And it builds all of the foundational skills that you need for.
And it tracks the learner's individual progress. So this is
Yes.
not a class progress chart. This will be one learner. They'll start agreeing, and as Brenda says in the comments, a lot of these tasks end with very cool certificates, which the learners look forward to achieving. So that's even better.
Yeah, I'm just going to skip the video because we're not going to watch the video now. So what happens over here, if you were able to play this, just to show you quickly how this thing works, and really the only way to kind of get your head around it is to actually go and do it yourself, to fiddle around and scratch around and see how it works. So over here, I've got my blocks that I need to move into place, the green part, and then over here, the red part that I'm going to highlight, this is my game screen, and I effectively have instructions here at the top. So here in blue that you'll see there, they are the instructions. So what I need to do is I need to make sure that my Angry Bird moves to my pig. So what I need to do in order to make that happen in this instance is I need to connect these blocks so that he moves forward twice. So we're going to say run, and then he goes once and he goes twice. And there we go. He has managed to get the pig. Now we're going to go to the next one. Louis, I'm going to leave the comments. I see lots of people are commenting, so I'm going to leave you to respond to that. I just want to show how this thing works quickly. So here I can see then that in order to get to the pig, I will need to go once, twice, 3 times. That's the visual world that you're imagining in your head, right? So that's the critical thing that we are talking about when we're talking about this abstract thinking concept of this world in your head. I need to visualize that I need to do that in order to get there 3 times. So we're going to run, he's going to jump, he's going to jump, and he's going to jump. Now, the cool thing is if you're doing this in your class, some kids will get this like that. Others won't, and that's okay. Don't stop the learners that get it like that. Let them go on and see how far they can get. And exactly as Louis has pointed out, let them help other learners. It's a social thing. It is a community. Everyone wants to learn together to get better at this thing. It's not a competition. There are no grades involved, as in I am the number 1 student and you are the number 2 student and you're the number 3 student. That's not the idea here. It's a club. A club wants to grow together, wants to build itself up as a group.
Yeah, but this is block-based coding, and admittedly, it's very concrete what you're showing them. A little Angry Bird moving forward. Later on, it does get more abstract, and when you get to typed as in text-based coding, of course, that's a whole new level of abstract. But when it starts, it is this beautifully concrete to abstract.
Right, let's move to like the level 12, see what I have to do over here. Right, so level 12, you'll see now suddenly this whole thing becomes more complicated. I need to have this idea in my head of what my Angry Bird is supposed to do here by imagining how this thing is going to work. So now there's like a whole bunch of TNT things. There's this weird pink thing. It says repeat, because I mean, ultimately coding is also just a language that you're learning. So I need to repeat something. Let's say I repeat it 3 times. So when I run, I need to move forward 3 times. So we'll go up to there. Now I know I need to turn right because in my head I'm visualizing this. Now I move forward once again. Now I need to turn. I think I need to turn left. Then I need to move forward move forward 3 times again. Let's just quickly run this thing. And this is the cool part. I actually get to see whether or not this is working. That is the whole idea of debugging something. So far, so good. So far, so good. Still so far, so good. But I'm not, oops, there I hit the block. Right. So now I immediately see, wait, there are mistakes with my coding. I can fix it by saying, don't move forward 3 times, only do it twice, for example. So I'm not going to go through this whole thing, but it gets way more complicated than just this as well.
But even with this, you are hitting abstract thinking, problem solving, sequential programming, as well as a loop, as in the repeat statement. Those are 4 key programming concepts. You're already doing that in this little Angry Birds one.
Yep. So the first time they do it as a grade 10 learner, it's not going to be that challenging because they've got some kind of reference at least. They might not realize it, but yes.
They're never going to realize it. I spoke to a university lecturer that teaches programming for postgrads and pregrads and undergrads. And he said that the learners that come into university with coding background have an advantage that the learners who don't have some coding experience never catch up to. Not undergraduate, not postgraduate. They never lose that advantage in what they have gained before they go to university and register for something like BSc Computer Science. So that's the advantage that we're giving them.
So I want to show you and there's a lot more in code.org that we're not going to show you, that you need to go and figure out yourself. But there is one thing that I do think is critical to understand here, that is how quick and easy it is to create classes, get learners onto that so that you can start tracking progress on that. And it's not just about tracking progress, it's about making it easier for them to know where they are in their own learning journey. So in order to do this, I'm going to have to sign in with a teacher's account. So I've already created an account. I'm just going to use continue with Google. For me, it's usually the simplest option, but you can use Microsoft or Facebook if you want to.
If anyone was wondering, it's super safe to continue with Google or Microsoft, whatever. It's actually one of the safest way to log in. They say it's safer than trying to just use the same password over and over or generate passwords you're never going to remember. So feel free to continue with Google in the websites like these, in my opinion, and what I've read, pretty safe.
Yep. Right. So they are working a lot on making sure that it's safe. Now, once I'm actually in here, you'll see I've got like 2 dummy classrooms set up over here. Amazing New Coding Club and Coding Club Yeah. Right. As you can see, they're not actual classrooms. There's only 2 students in them. These are just examples. But what's cool now about this is if I go into Amazing New Coding Club and I open it up, you'll see I've got 2 students in here. And I can see the progress of these students. There's Jaco. Jaco has at least done something there. Louis has done nothing. And I can get even more detail on this, what they've actually done, by going to this levels. You'll see there. So Jaco's actually watched the video and done level 2, 3, 4, and 5. And here in this way, I'm actually able to keep tabs on where everyone is, which is amazing for me to kind of get a sense of what is happening in terms of this. So they've literally, in that question about a curriculum, there is a curriculum, if you want to call it that. I don't prefer not to call it that, because then it feels too much like school and not enough like a fun extramural club, because that's the critical thing for us, to get that message across. And for me, probably the coolest thing about all of this is the way they've thought about the whole logging in process. Because one of the biggest problems we have with any kind of thing is our younger learners especially do not have even email accounts. They don't understand how email accounts work. So this is, for me, such a cool thing that you can do. If I create a classroom, you'll see here one of the options I have. I can use personal logins for my older learners who have email accounts and understand how it works. If I'm using the Google platform, I've got a Google Classroom. I can use that, import those names, those email accounts, etc., etc. So if you are already a Google school using this, it works. It's so easy to set up. For our younger learners, they've got this option of a picture password. And then the secret words, which is like password light. Play around with it. You can use either one. But this picture password thing, for me especially, for our kids, I'm thinking of our learners who might be in situations where they haven't had a lot of exposure to this thing. So I'm going to use the picture password. So this is yet another amazing coding club. I'm going to say this is going to be grade 3, 4, 5, 6, 7, right? So, or maybe we'll just include the grade 3s. Now, I can pick and choose. Remember, the learner is going to get confused when they open up code.org the first time and they don't know where to go. I pick a curriculum for them. So let's say I pick middle school, or let's pick elementary school. So here are all the different things that I can use. I like the Express course. I think this is a good kind of one to go with, CS Fundamentals Express course. So that's the one we've been looking at now. I can click on it and I say finish creating sections. So I'm going to create a new class effectively. They call it a class section, but it's effectively a new class. And then I'm going to add students to this. Let's add some students. And when I add my students, so here I pick their names. So let's just keep it simple. We're just going to say Jaco and Louis are going to join the third class. Not typing correctly now. So there's Jaco. He is 13 years old. I think the only one that's actually required is the name. So we're going to say add. And we will have another one, Louis. And we're going to say add. Right. Now, when they're going to log in, they're actually going to use these pictures. So Jaco is the dragon and Louis is the chicken. I can reset it over here when you've created your things the first time around. You can print your login cards that you can hand out to your learners. You'll see they've even got a parent letter that you can download. You can do all sorts of interesting things with this. When you say add multiple students, you'll see it opens up a thing where you can just copy and paste the list of names and it'll generate it with a list of names. So very easy, very functional. And then when I'm actually going to log in, this is the part that I think is the coolest. So when I log in and I share that link with them, so you can typically, however you're going to send this link to them, if they're going to have it on a, sorry, I just need to log out quickly. Sign out. Right, you'll see if you share that link with them, their class link, they see this. Again, simplicity of use, the ease of use. They just select a name. They either click on Jaco or Louis. Let's say they use Jaco. Jaco was the little dragon. They select their dragon and they say sign in. And now once they've signed in, immediately they get to this point, which shows them these are the things you need. It turns green if you've done it, and then they can get going. Simple as that.
You can also see that a lot of these skills, the sequencing, the sprites, the events, they're kind of game-based. Angry Birds, Dance Party, Minecraft, conditionals in Minecraft, maze things. The kids love that. This is very well thought out, and I love it. Are you also going to show them the lesson plan, Jaco? Or should I show them quickly?
Louis, I think we are running out of time, to be completely honest, because we've got like 10 minutes left, and we actually want to still cover one or two other things.
Doesn't matter. There is a written out lesson plan with all the skills covered. If anyone ever wanted like the full I'm a teacher, impress me with your amazing theoretical knowledge of teaching, then you can give them the printed out lesson plan.
There we go. So yes, as Louis pointed out, explore. Code.org has so many things in it, and we've only scraped the surface of it, but we do want to show you something else that both of us find very, very, very cool. And that is a thing, the next one that we also want to, oh, sorry, where am we now? Where we also want you to go and check out is Code Combat. So Code Combat is something that I introduced Louis to. Louis, what's cool about Code Combat while I load it up here on my end?
Okay. Code Combat is once again an RPG game-based learning environment where they teach you. You can choose between languages, just choose Python. Don't even argue. Python is the best first language, the easiest for anyone to learn. If your kids ask, Python. Okay. Then it's immediately gamified, cute, nice music, exciting. You get a character, it levels up, you get equipment, but you do this through coding. And the coding that you do is all typed, as in text-based, which is, of course, where all of this goes. I mean, the block-based coding you have to do is very powerful and very cute and nice, but eventually we're going to build towards typed text coding, and that's where Code Combat comes in. I would, without hesitation, I would do something like half an hour code.org, and I would do 25 minutes, half an hour Code Combat in my club, if that's what I was running, just because it brings a whole new element. Or I would see who is interested. I wouldn't force the kids to do both, but if there is a kid that wants to do both, I would definitely not neglect showing them both of these options. That's how I would run a club.
Okay, now I see what the issue was. I was trying to realize I am actually logged in to something. Right. So let me just quickly log out. Or go to. I'm going to go to my courses. So I'm playing it now as a student, not as the teacher. So we won't show you this part of it, but Code Combat has the same functionality as code.org, where I can create a class. I can add learners to the class. I can assign them. I see Aaron has now pointed out he used Azaria last year. Azaria, if I remember correctly, is also just effectively one of the modules that you can assign to them, like we use the Express course. Code Combat, for me, in the playing around with it a little bit, just gets to the point where it, can go way more complicated. It really can get very complicated. But the other part, and this is the part that got Louis very excited about this, is you'll see here what's different is I'm not doing block-based coding. I'm actually writing out code. So you'll see here that I'm supposed to move, and then I'm supposed to type out euro move down.
Jaco, I don't know if it's just me, but your screen and your camera completely froze. So we're hearing you, but not seeing anything. Do you want me to just quickly show them Code Combat?
Yes, nope. Yes, if you can show them on your end.
Okay, let me just get that screen over here. Okay.
Is my screen not showing, Louis?
Don't want to do that. No, your screen is not showing.
Okay, sorry, Louis, but in chat they are saying it is showing.
Okay.
Okay, cool.
My connection for some reason.
Okay, so you can see here, I'm actually typing out the instructions. I'm not doing the click and drag thing that it says. So here, it tells me here, look out for capitalization, should be euro move down. So there's debugging immediately integrated into this. So suddenly it changes things because that has to be accurate. It has to be the way that they tell me it's supposed to be. So there we go. We're moving our euro, moving him, and then we get the gem, and yay, we have won this. Finish this level. We're going to say done, and it takes me to the next level. So here I go on to the next level. They've got these little videos that they kind of explain things to you. I'm going to skip it. So you'll see it's a very, very, very gamified. It is Python. You can actually switch. It does allow me to switch between Python and Java. I've just chosen the one, but as Louis has pointed out from his experience, choose Python.
You can choose between Python, JavaScript, CoffeeScript, Lua, C++, and Java, but just do Python.
Yes, so you can choose a lot. I want to show you something here as well. What I think is really cool is, like, when we get to like this last level, for example, suddenly you'll see there are new things that get added to this. Now I'm supposed to, there's like monsters there that want to kill me. I need to make sure they can't kill me. There's a whole kind of issue that needs to happen here. Okay, I've already played this thing, so let's just run and see what happens. Okay, nothing is happening. They haven't seen me yet. But effectively, this time it's different because I'm going to use this idea of moving down. So I'm going to say euro, there we go, euro dot move down. And then when the euro moves down, he gets there. Now they get to me. They want to actually, they see me and they're going to try and catch me. And unfortunately, they've managed to catch me. So now I need to go and say euro, build XY. So I'm going to build a fence. I need to make sure where I'm building the fence. I need to build it at 36 and 34. So you get the sense what I'm saying. It becomes a lot. It's no longer just the little click and drag things that you're doing. You're doing more complicated problem solving here in what it is that you're trying to achieve. So that's 3627. So I need to build 3 fences. Okay,
Yeah,
so now let's
later
see.
on, you have full functions and methods to solve these problems. It's really quite complicated, diving into the grade 11, grade 12 curriculum completely. And if you look at some of the other options, I see that the free version of this brings you syntax, methods, parameters, strings, loops, variables. And then you get the choice between different things. Some of them are free or not. Some of them are web development, game development, etc. So between all the offerings that Code Combat gives you, just the free options alone are going to keep you busy for many, many months if a kid actually solves all of the levels, which would be brilliant if he does. Otherwise, it is $9, $10 a month per kid. Of course, you can always talk to your principal about your 10% of your LTSM IT budget and see if he wants to get a software subscription for you or someone if you want to check out all the different levels. But the free version alone is quite amazing.
It really is. So with those 2 options, and again, we could keep you busy for a very long time with that. So Deirdre, in terms of starting, Louis, your opinion?
Well, they'll have to type and they'll have to understand. So I would say this is more for grade 6, 7 onwards type of thing. I would say grade 8 and 9, perfect fit for Code Combat. I wouldn't go for grades 4, 5s, maybe not even 6s with Code Combat. There's enough in code.org to keep them busy.
Yes, I think a kind of a cool transition from that is once they get used to this code.org thing, moving into Code Combat makes a lot of sense. And then moving in from Code Combat into your things like CS First, etc. There's a lot of other options that you can add to it, which have been added onto the other things. So the critical thing is just actually start exploring. We are kind of done with our time, but I think we would be remiss if we do not talk about this next concept as well. Just quickly, we're going to really go through this very quickly, Louis. Our time is technically finished, but so those of you that we kind of have told our story, starting your coding club, that is the critical thing that we want people to understand. However, you will be getting the recording, so you will have access to the recording. We don't share the PowerPoint necessarily because the PowerPoint on its own doesn't really mean that much. So the lights and the brights, this is a term my director loves to use. The concept of the lights is what is here and now, and the brights is where we're building towards. Where could this go? So that is where the coding and robotics, for me, when I look at it, how I like how this works together. The sense that coding is the thing we see as the lights, because you kind of have everything you need in place. Most schools have things in place that they could get going with this thing now. But the robotics, whenever we add the robotics, this is the brights. This is the kind of element that gets added on. Louis explains this in I think, a very kind of practical way. Yes.
Quickly give you the rundown on the 2 robotics things that I would look at. There are more and that can be great, but the 2 that I would immediately look at, either the microbit one. The BBC microbit program looks like that, little cute device. And I've been exploring some of their lesson plans, and they've got a brilliant curriculum. It can be gamified if you want to. It can be just project-based. They guide you through it. They have a teacher training portal, which we link to in the document. You can upskill yourself before you even think of buying this for your school. It's very good. It's about 500 Rand for a starting kit for the microbits, and it's concrete, hands-on. We're starting with robots. Or there is the first SA Lego League. Now, the Lego League turns your club into a sport where you compete against other schools. Now, that's the Spike Prime kit over there. That's about 10,000, 11,000 Rand on Takealot I saw. and you have to a 3,000 Rand yearly subscription to the game board that you're using this year in the club. And then your kids upskill. They've got teacher material, learner material, just like the microbits. And then you compete against other schools. That takes your club from just cerebral, we're doing cool things with robots, to now we're competing against other schools in a very sports-like, formalized manner. And I would say the Lego one is by far the coolest robotics kit because it comes with that league and that competition element as well. So if I had the money, then I would go for the Lego kits. You can get them for free. Me and Jaco spoke to one of the senior people on the board that gives people free first essay Lego kits. You have to go to their site, click on grant, fill in a Google form, and they send you 2 or 3 of these kits for free. And as long as you run the club and compete, they give you training as well. You get to keep the kits. I even know a school that complained, said 3 wasn't enough, and they got 3 more. So these kits are available for free. They just don't have enough people filling in the Google form saying, yes, give us like 33,000 Rand for free, and we'll run a coding club and compete against other schools. I don't know why, but the link to that is also in the document that I'm going to share with you. So if you want to go fill in a Google form and do that, that exists. And it does make it more complicated. I would start with Code.org and Code Combat, but if you wanted to jump into robotics, those are the 2 elements that I would explore. The microbit one will work really well for your in-class as well, just incorporating into your lesson plans and in your classes. The Lego robotics one is solidly, this is a club, you're competing against other schools.
The one thing that I think is important to note is filling in the Google form doesn't guarantee that you will get the spy kit, but if you, it's kind of the same as the coding, as the whole coding club. 100% of people who do not fill in the form don't get it. So if you don't fill in the form, you never know. I think it's critical to consider doing those things, but I love the idea that Louis pointed out. Code.org is a great place to start. Code Combat is a great place to continue with that. The robotics for me is something that gets added on later and really just extends it and expands it. What's wonderful as well to see in the chat, and I see there's lots of people that are commenting on things that they've used. Tinker is great, that they've been using. And look, there's a lot of amazing tools out there. There really are a lot of amazing tools out there, I feel. And we're not trying to say one thing is better than the other. From our experience and from Louis' kind of background as an IT teacher, he looked at the stuff on Code.org, he looked at the stuff there and felt that's great. That's not saying that the other things aren't great. They are. There's vast resources out there, and exploring those resources is the most important part. Finding those resources, but at the same time, what we also caution against is you can quickly end up having spent 9 months, 12 months just exploring resources, and you still haven't started with anything. Just trying to find the perfect thing.
I've seen teachers get told by principal, explore the options, what robot kits should we buy? And then they take 9 months, they buy no robots, and they could have started the coding club for free 9 months ago already. That's why we gave you 2 options today, which we think are good. And I know the schools that run microbits, some of them do reach robots and they're great. Some of them do microbits, some of them do Lego robots. I mean, some of them do Arduino stuff. Don't care. The most effective ones that I've seen, in my opinion, microbits and Lego. If you do something else that's brilliant or someone sponsors it for you, go ahead, do that, use it. We just wanted to simplify some of your choices today so you don't spend 9 months wasting time exploring options instead of having options in front of you immediately.
And I think one of the most exciting elements of the Lego robotics that we would love to bring into all of this, Lego robotics really tries to create a social community of schools supporting each other, schools growing together. The same as when people are mentioning, you do this, we do that, we do our school. We want to encourage you to help your schools in your area get going with things, share your expertise. The more people who get on board with this thing, the more people who learn how it works, the more people who start these things, the better it's going to be for the organization as a whole. So with that said, we do want to say, very simply put, thank you. Thank you very much for attending the session. Good luck. We really hope to see coding clubs popping up all over the place by this time next year. We want to be overwhelmed with the number of coding clubs that have started. We want you to tell us what to do. We don't want to be the ones that are telling you. The great thing is, if I'm looking in the chat, Louis, I think there's a lot of people out there that could be telling us what to do instead of us telling them or making suggestions. So it's great. It really is great to see that things are moving, things are picking up. There's enthusiasm around the topic, and we really hope that we continue growing and we continue seeing more of these clubs popping up all over the place.